Running in the browser, Blazor often lives side by side with JavaScript components and libraries. Dependency Injection provides a reference to the browser's JavaScript runtime, and the built-in interop mechanisms make it easy to call from Blazor into JavaScript and vice versa. Data passed as call parameters or returned from functions is serialized using JSON, and property naming conventions are translated automatically. As a developer, you need to make sure that JavaScript functions you want to call are accessible from the global window object. When calling Blazor from JavaScript, methods must be public and decorated with the JS invocable attribute. The following demos cover several possible scenarios, including synchronous and asynchronous calls and static and instance methods on the .NET side. They also show how references to HTML elements as well as .NET objects can be passed to JavaScript. To begin this demo, I add two JavaScript functions to my demo application. Blazor identifies elements by name within the browser's window object. I add a script block with the two functions to the index.html file. Of course, the functions could be in a separate file in a real application, but I'll keep it simple for the demo. The first function outputs its parameters in the JavaScript console. This makes it easy to see how data is transferred from Blazor to the JavaScript runtime. Note that the function returns a value. This is technically required due to the implementation of the interop mechanism. The value is meaningless in this case. The second function returns an actual value, an object type, and I'll use it to show how data travels back into Blazor. I edit one of the pages in the project, and I add the @inject statement required to access the JavaScript runtime from a Blazor component. In a nutshell, this directive creates a local property called JS of type IJS runtime and injects the service reference. I add a function to the @functions block. It calls the JavaScript function debug_out and passes a string as well as the other two parameters accepted by the implementation. Invoke async assumes a return value, so I use bool. Calls from Blazor into JavaScript should be asynchronous for compatibility with Razor component deployments. I add a button to the page that calls debug_out_string when clicked. I run the application and bring up the page with the debugger on the side. I click the button and you can see the debug output appear in the console. Back in code, I add a simple class called person. Here is a second call to debug out that receives a class instance as a parameter. I add a second button to the page, build, and change to the browser again. This time, the debug output shows an object with properties. Note how the serialization mechanism has automatically adjusted the property names to JavaScript conventions. To demonstrate how you can receive data from JavaScript, I add a second class. Note that I'm using C# naming conventions for the properties, so they begin with capital letters. When data is serialized from JavaScript to Blazor, the receiving type in C# can use property names adhering to either C# or JavaScript naming convention. I add some code that retrieves the object from JavaScript and another block of HTML to show the object when it's available. Once more, I build and reload. The data object is retrieved correctly from JavaScript and its content shown in the UI. As a final example for calls into JavaScript, I add two script tags to the index.html page, loading an external library called Data Transformer. This library has functionality to reshape data structures. Here in the file demodata.cs, I've prepared a sample, a hierarchy of two nested types using both generic lists and arrays. In addition, there is a class transformResult, which matches the flattened shape of the data I expect to receive from data transformer. Back in index.html, I add a new JavaScript function called transformData. This is an important step you'll most likely need to make when working with Blazor JavaScript Interop. Since the functionality of the invokeAsync method is limited to function calls on the window object, any extra steps are hard to perform directly. In this example, array.from is called on the transformed result because the library works with generators and those can't be serialized back to Blazor directly. I edit the page data transformer. Everything is already in place here to call the transform data function when a button is clicked and to display the result set once it has been returned. I inject the JavaScript runtime and I add the invokeAsync call using the expected result type and passing the demo data. I change the signature of the transform data method as required. I build and run this example in the browser, and the result shows the flattened data structure as expected. Now it's time to consider the opposite direction for interop calls, from JavaScript to Blazor. I add a class to my project and call it .NET Data for JS. I declare the class static and add a method decorated with the attribute JS invocable. Note that async functions are also supported. For comparison, the equivalent implementation would look like this. Of course, you would normally use an async function if you have an awaitable result to deliver, so this example is just an illustration. I add a snippet to my script block to call the Blazor function every 3 seconds. I pass 2 parameters to invoke method, the name of the assembly where the function can be found, and the name of the function itself. The function is assumed to be public, static, and decorated with the JS invocable attribute. I build and run, and you can now see the output coming up continuously in the browser console. To complete the example of the async method on the .NET side, I could call that method from JavaScript and have a promise returned. Of course, this means that I could use async and await syntax in JavaScript as well. Now you've seen how to call static .NET methods, but it's also possible to call instant methods. I edit the page calling .NET instance and inject the runtime as before. Then I add the function request.js callback. This uses invokeAsync as before, but it passes a reference to the current instance of the component by wrapping it in a .NET object ref. In my script block, I add the JavaScript implementation of request.js callback. The parameter callbackReceiver contains the reference to the Blazor component at runtime, so I can use it to invoke a method on that object instance after a delay of 1 second. Back in the component again, I implement the instance method that will be called from JavaScript. As before, it's public and decorated with JS invocable, but of course, it's not static. I add a button to trigger the callback request. I build and run. When I click the button, you can see how the callback is requested and then performed after the short delay of 1 second. Now you've seen the basics of JavaScript interop in both directions. As a real-world demo, I've brought up the data layer sample I used in a previous video. It shows a set of country records in a table with sortable columns, and there's a data layer implementation that loads the information from a web service. For this demo, I'll use the DevExpress chart library for JavaScript to display an interactive chart next to the table. I begin by adding JavaScript and CSS entries to index.html. I'll use a jQuery binding for this implementation. To define where the chart is going to appear, I integrate it into the rendering in index.cs.html. The plan is to have a component called country chart that receives the same data that is displayed in the table. I create the new component country chart and add some code. A new element in this component is the ref tag on the div element. This is coupled with the field of type element ref in the @functions block. The field has the same name that is passed to the ref tag, and the connection is made automatically. In the call to invoke async, the element ref value is passed to the JavaScript function, which provides JavaScript with a reference to the specific HTML tag it's supposed to work with. This is also the first time I show an implementation of the onAfterRenderAsync method. This lifecycle method is called by Blazor after the component has been rendered completely. It's important to wait for this point when working with element refs because they are invalid at earlier points in the rendering process. I edit index.html and add the implementation of the function initCountryChart. The syntax is largely specific to the jQuery initialization mechanism of the DevExpress chart component. The chart element receives the element ref I discussed a moment ago. It represents a valid DOM node and is passed to jQuery directly. The data collection is assigned to the chart as a data source. I build and run the app. The chart comes up next to the data table, showing 2 series for the area and population values of each country. Blazor handles updates automatically, so the chart changes when I modify column sorting. To complete the sample and make the chart interactive as promised, I edit the country chart component and add 2 elements. Chart point clicked is a method that can be called from JavaScript with an ID value. This will be the ID of a specific data object. The method calls the delegate onChartPointClicked as an event handler. To enable the JavaScript chart component to call into the Blazor component, I add a parameter to the initCountryChart call. This transfers a reference to the component instance to JavaScript, as I demonstrated earlier. On the JavaScript side, I add the corresponding parameter to the function and an event handler for the onPointClick event. This handler calls back into the Blazor component and passes the ID of the data object associated with the series point that's been clicked. I edit index.cs.html to take advantage of the new event handler on the country chart component. I add a snippet to the @functions block of the page to handle the event, store the currently focused country ID, and return a conditional CSS class for a table row. I add a class attribute to the TR tag of the country table. This uses the helper TableRow class to assign a special CSS class when the data row is the currently focused one. Finally, I add the attribute to the country chart tag that hooks up my event handler with the chart component. This completes my implementation and the JavaScript Interop demonstration. I build and run the app, and now I can click data elements in the chart to focus the corresponding data row in the table. That's it for this video. Make sure to keep up to date with all of our YouTube content by subscribing and ringing the bell. Thanks for watching.